Hello, welcome to a video for grade 12 physics on vector component addition. In this video, we're going to take a look at the first bit of vectors, a little bit of review of what vectors are, and we're going to take a brief look at how to add these together using component addition, which is sort of the basis of most of our vector addition here. Now remember, a vector is any quantity that has both magnitude and direction. So whenever you take a number and add a direction to it, you get a vector. This could be something like 3 meters east. You got a magnitude and a direction. Now let's start off really quickly by taking a look at our first example here. This is in your example package, so take a look. So this one here, we've got 3 different vectors, and we're trying to find the magnitude and direction of the vector sum. Now you may notice we're looking for the sum s here. Hint, this little arrow above the letter indicates that it's a vector. And I've got a plus b minus c. So what I'm trying to do is I'm trying to add these 3 vectors together, positive a, positive b, negative c, and work my way through there. So a couple of things. Remember magnitude. Another name for magnitude is the size or the number attached to it. So the distance or something like that. The direction here is direction is an angle or a cardinal direction, or something else like that. So let's start off by solving this, and then we're going to discuss it a little bit and see what we've got. So my solution here is S is equal to A plus B minus C. All of these are vectors. So there's what I'm trying to add, and I've just copied this from here. Now, when I'm writing a vector, I can write this in component notation with my x and my y coordinates above each other. So I can write A as 3, 1, like this. That gives me my component notation with x and then y. I'm adding in B here. B is 6 and minus 1. And I'm subtracting C, and C is negative 4 and 2. Like that. So this is the math problem I've got. Now looking at this may seem a little bit strange or confusing, but this is called component notation, and we can just add and subtract them. All we need to do is add and subtract the x and the y components separately. Pretty straightforward. To find my x component here, I'm going to go 3 plus 6 minus negative 4. So my x component is going to be 3 plus 6 minus negative 4. And that is going to work out to 13. My y component, I'm going to go 1 plus negative 1 minus 2. And that works out to negative 2. Those are the x and the y components. Now I can write my solution here as s is equal to 13 over negative 2 in component notation. Or if I prefer my notation that we're used to from math class, I can write 13 comma negative 2 like that. So I've got my x and my y components. So this is component addition and subtraction. A couple of things to note. So I'm going to call this here component addition. And the hint here is that we add x and my y separately. Okay, so I can add the x and I can add the y separately, and that allows me to figure out how this vector is going to look. So a couple other things that I can do is, please also note that the units here will be based on the question as we figure that out. This here gives me my vector s in component form. But if you notice, my question actually asked for the magnitude and direction. So 13 and 2 is not in magnitude and direction. This is in component form. So I need to turn this into a vector with magnitude and direction. So here's S, and this here makes me a little triangle. So I'm going to just sketch out a little triangle. That's 13 on my x and -2 on the y. What I'm looking for in this triangle is I'm looking for the hypotenuse of this right angle triangle. I'm looking for the hypotenuse. That will get me my magnitude. So the magnitude in this case is the hypotenuse. The direction is going to be this angle here from where we started. So this angle here is going to be my direction. So starting off, my magnitude, I'm going to go, hey, you know what? I've got two sides to this, 13 and 2. So I can use a squared plus b squared equals c squared. Or if you prefer, x squared plus y squared equals my resultant squared. So I've got 13 squared plus -2 squared. And that works out to 13.15. And I don't have units here because I didn't have units in the question. So this is my magnitude. There's my magnitude. My direction, all I need to do is treat this as a little trig problem. I'm looking for this angle here, and I've got these two, so I can go, my direction is the inverse tan of -2 over 13. Remember, tan is opposite over adjacent. This is my opposite. This is my adjacent. So there's my angle there, and that works out to 8.75 degrees. Notice we started here and we're turning this way. So we're turning sort of clockwise in this case. The way that we refer to that is I can say 8.75 degrees south of east. I started at east and I turned to south. So this is south of east. And this is my direction here. So to write this in magnitude and direction form, I would say my vector sum, there's my correct notation for that, is 13.15, and this is 8.75 degrees south of east. Okay, so this is my final answer right here. There we go. All right, other things to note. Note that here, to find my magnitude, I used Pythagoras. So this is a squared plus b squared equals c squared. If you prefer, this actually works out to the square root of x squared plus y squared. To find my direction here, we're going to use SOHCAHTOA, and in this case, we're doing inverse tan of y over x. And that works out to get me my direction here. So these are a little shortcut to go from component notation, so this is component notation, to my magnitude and direction format. Okay, this is a quick look at component addition for vectors. This example is in your package. You may want to work through it as well and see if you can get the same answer as I did. Hope you have a great day, and I'll see you later.